Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy and we're doing something a little bit different today. I've got a late addition to our How to Write a Problem Solving Modelling Task, a PSMT series. So this is called Defining Variables. Now this also has some general crossover. If you're studying science and you need to write a scientific investigation report or some sort of research report, or if you're in mathematics, regardless of whether you're in Queensland or not, and you're wanting to understand how variables affect a report that you're writing of some kind, this is the video for you. So in this video, what I'm going to cover are a few things. Firstly, I'm going to talk about what variables are. Then I'm going to show you some applications in writing a problem-solving modelling task. So that's specific to Queensland, Australia, but there are also applications to writing maths assignments anywhere in the world where you're doing that. I'm also going to look at an application to graphing and also an application in science as well. In any scientific experiment or mathematical investigation, we want to conduct what is called a fair test. This is so that we can rely on the results we find to draw accurate conclusions or make predictions. To conduct a fair test, we want to change one thing only, and then we measure the impact this change has on the results. Consider a situation where I wanted to test the different rates of growth or seeds given different amounts of water. I'm going to plant my seeds in different pots and then give each pot a different amount of water. I'm then going to measure each pot at the end of the experiment and see how tall each plant grew. I'm only going to change one thing from each pot. That is the amount of water, and this is the independent variable. Then I'm going to measure the growth of the plants. This is the dependent variable. Typically, we would expect the independent variable to have some sort of effect on the dependent variable. We know that there are other factors that affect how tall the seedlings will grow, not just how much water they receive. Sunlight, the quality of the soil, the type of seed, fertilizer, all of these are factors that can cause a seed to flourish or fail. In any investigation, we want to keep these other factors the same, so that we are only measuring one thing at a time. That way we can see how only one thing impacts the seed's growth. These other factors that we are going to keep the same are called control variables. So in the case of our seedlings, we would make sure they all got the same amount of sunshine, the same amount and type of fertilizer, the same soil quality, and the same seed type. So firstly, we have some little memory tools. Our first memory tool is CMS. You'll notice that I've got those in red down the bottom. They are the things that we want to remember about each particular variable. One changes, one is measured, one stays the same. Now, there's lots of different acronyms out there. The one I use with my class is Cows Moo Softly, CMS. That's how we remember it there. It's a nice little visual about cows. But the problem is with that is that most students don't understand which one goes with which. Cows move softly. So they might remember that one changes, one is measured, and one stays the same, but they don't necessarily remember the order being independent, dependent, and control. So I've added to CMS with an I, a D, and a C. Independent, dependent, control, meaning I don't care. So cows move softly, I don't care. So that's a good way to remember cows move softly, and then I don't care straight underneath that. That will tell you then that the independent is the one that is changed, dependent is the one that's measured, and that the control variable is the one that stays the same. So that's a little memory tool to help you remember which one is which. Okay, so you might be wondering, how do the variables relate to writing a mathematical report? What's it got to do with maths? Well, firstly, when we're doing maths, we're typically investigating some sort of problem that we need to solve. And in this, there can be lots of factors that cause and affect different things in our study. So the first part of our problem-solving modelling task in Queensland is that we need to do a formulate section. And we usually talk about variables in that part of the formulate section. So you could either put this as part of your introduction. You could actually state it with a subheading that says variables definition, and you would simply be stating, it's a very simple thing, the independent variable is this, the dependent variable is that, and these are the control variables. You may not even need to mention the control variables there, because in a maths report, we're really only focusing on two variables, independent and dependent. However, if you're doing a science research investigation of some kind, you're going to want to measure the independent and dependent variables and state those as well. Typically, this is done as a prediction of some kind. So you might be starting your science research report with a statement such as it is predicted that the independent variable, whatever that is, will have an effect of this kind on the dependent variable. So you're going to make some sort of prediction if you're doing a science investigation. You can see there's a little bit of a difference between maths and science. But typically, whether it's science or maths, and whether it's a report or a PSMT, no matter where you are in the world, this is the kind of thing you would put as part of your introductory part of your assignment. Now here's where it gets interesting. In a PSMT, we have to have a subheading as part of Formulate called observations. Now, our control variables can be observed as having a possible impact on the results. Now, this is where it's important, even if you're doing a maths assignment, to think about what those control variables are. You might, for example, know that your independent variable is the amount of water that you're putting inside the plants. Your dependent variable is how tall the plants grow. However, you've got all these other things that are going to cause an effect on how tall the plants grow, like the sunlight, like the type of soil, that sort of thing. So when you're stating observations, if this was your experiment, you could say something very simple like, it is observed that the amount of sunlight also has an effect on how a plant grows. You might even want to use a quote or a citation or a reference off the internet to support that observation. So it's a good idea to have a think about what are all the other possibilities that could affect my results. These become your observations. In turn, they also become your assumptions. You need to assume your control variables remain the same to have a fair experiment. Now, this is where real life is difficult because we know for a fact that sometimes some situations, they have multiple variables that are taking place. Lots of these things that are supposed to be staying the same as control variables really don't stay the same. But we have to assume it's a fair experiment in order to discuss it and talk about it in our report. So that's why you're making the assumption, you're pretending that these control variables are staying perfectly the same every single time you run the experiment or run the investigation, and that way you can assume it's a fair experiment. So when you're stating your variables, you can actually refer to these control variables in your assumptions by assuming they stay the same. So you observe that sunlight has an effect on how tall plants grow, and then you assume that the sunlight will be the same for each plant to maintain a fair experiment. Big clues here. Okay, then later on in your report, you're going to talk about, you're going to evaluate your results. You're going to think about how those results, whether they were fair, whether they were reasonable. Did your control variables really remain the same? So that's when you need to reflect now. You might have had 3 or 4 control variables that you tried to maintain as the same, but did they really stay the same? Was that reasonable for you to assume that they were going to stay the same? If you had your plants in the same place, then you can assume they've all got the same amount of sunlight. So that is a reasonable assumption. If you have pulled your potting mix out of the same bag, you can assume that the soil is the same in each plant. Now that is going to provide limitations to your result. Whatever has been an unreasonable assumption now becomes something you evaluate and talk about, and then you can talk about it again as a limitation to your results. We're now going to have a quick chat about graphing. Most of us by senior school should know how to graph things, but knowing which is the independent variable and which is the dependent variable is really important because we put them on particular axes. So we usually start off by presenting our data from an investigation or an experiment as a table first. So this is the table of the experiment that I've conducted with the plants and the water. Now you'll notice here that the top row is going to be my independent variable, always on top. And the second row is always my dependent variable. So this could also be presented in a flip. You could actually have the first column as the independent variable, and then typically the dependent variable goes as your second column. Either way, it's usually first independent, second dependent. So now I've got my little table down on the bottom of the screen. I've now got my axes that I'm going to graph these results. Now my x-axis is my horizontal axis. This is where I go across left to right to graph my independent variable. So from this column here, I'm actually creating ordered pairs for my Cartesian plane here. This will be my x value, this will be my y value. So we go across horizontally first, and then we go up and down second. So these are my side to sides and my up and downs. Okay, my y-axis is my dependent variable. That will be on the vertical axis here. So that's taken from this row here. Okay, and if I was to graph that, this is what it's going to look like. Now, you'll notice, let's have a look at this first set of coordinates, 20. So we come across 20 and then up 10. And we can see the 10 comes from here. Our second point, 30, 15. We come across 30 and then up 15. 40, 22, across 40, up 22, and then 50, 35, we come up there. Now, it's very important that if you put any graph inside an assignment, that you always talk about it. It's not enough to just stick it in there. You've got to mention it as well. Of course, you need to do the important things about graphing, which is making sure you've got your axis titles and a title, and that your axis titles also include units of measurement. Like down here, we've got milliliters and centimeters. That's an important graphing communication skill, but it's not enough to just dump it into an assignment. You've also got to mention something about it. So I'd actually be talking here about the fact that as the amount of water increases, then the size that the plants grow also increase. This is positive growth. You could also say that there is some sort of positive correlation. However, with only 4 points is not enough information for us to decide what kind of correlation we've got, but it almost looks like linear growth or even non-linear if you consider this could potentially become an exponential curve. But we'd really need to investigate further in order to be able to make that determination, because it's possible that we get to a certain point where we add so much water to the plants that our model falls down and the plant growth actually declines. So you could even see a situation like that as well. So these are the kind of things that you could talk about, because these are the limits or the boundaries of what data you've collected. You don't know what happens to the seedlings when there's 5 mils of water. That's outside the data. You don't know what happens when there's 100 mils. That's outside the data as well. You can only really make comments on what's going on with what you've measured. But it's important to talk about it in your assignment. So I've just actually shown this here on the graph. It's also a good idea if you talk about a particular point in your assignment to actually annotate your graph. That's what these dotted lines are here. So for example, if I wanted to talk about the fact that the smallest measurement created a minimum of 10 centimeters of growth, then I would actually take that data from here and I'd actually draw that onto here. I'd possibly even consider putting the coordinates and writing those onto the graph there if that was possible. And I'm sure that's possible if you were hand drawing it or if you took the time to find out how to do it in Excel. Well, did you find this video helpful? I sure hope so. Please engage with us further on Facebook and Instagram. You can also tell us in the comments, like and subscribe, and hit that notifications bell to know when there's always a new video available. If you've got any questions about what you've seen today, or you need a little help defining some of those variables, contact me at mcclutchymaths@yahoo.com. Well, thank you so much for your time. Have a wonderful day.